Welcome back. You are listening to another deep dive into theory of constraints, and it's really great to have you with us today.
Yeah, thanks for having me. I'm excited for this one.
So, have you ever looked at a company report, or maybe even just like your own team's performance dashboard, and noticed that your productivity is supposedly shooting through the roof, but somehow,
Right.
well, morale is totally in the tank, and the actual output feels worse than ever.
Oh, yeah. It is a paradox that drives managers absolutely crazy.
Right.
You look at the spreadsheet, and the spreadsheet says, everything is great. We are more efficient than ever. Then you look at reality, and reality says the ship is actively sinking.
And that is exactly our mission today.
Yeah.
We're unpacking this really fascinating white paper published in July 2026 by Dr. Alan Barnard. He's the CEO of Goldratt Research Labs. And the paper poses this very simple, but honestly slightly terrifying question.
Are you measuring the right thing?
Exactly. The core mystery we're going to solve for you today is why organizational productivity metrics so often show these massive, quote-unquote, improvements, while the actual performance and the profitability of the company just quietly declines.
What is genuinely fascinating here is where that core question actually originates from. If you're familiar with Dr. Eli Goldratt's legendary business novel, The Goal, there's a famous scene that captures this trap perfectly.
Oh, I love that book.
Right, so the main character, a plant manager named Alex Rogo, is proudly telling his mentor, Jonah, that he just installed some new robots on the factory floor. And, because of these robots, productivity in that one specific department went up by 36%.
Which, that sounds amazing. Any manager in the world would be expecting a huge pat on the back for a 36% bump.
Right, he totally expects high praise. But Jonah just looks at him and asks, so, by installing robots, you are making 36% more money. Yeah, and Alex is completely baffled. Because the answer is no. In fact, the company's overall profitability was actually going down, even though this one local productivity metric was just soaring.
Wow.
That simple, piercing question really exposes the extreme danger of local productivity metrics and that tension improving the part while unintentionally destroying the whole that's going to anchor our entire conversation today.
It's so easy to dismiss that as just, a scene from a novel, though. Let's look at how this trap springs in the real world, because Dr. Barnard didn't just write a theoretical paper here. He actually lived through the fallout of this exact scenario.
He really did.
Let's jump back to 2003. Tony Banta is the executive VP of worldwide operations at Cisco Systems. And Tony is staring at the exact same robot's inconsistency that Alex Rogo faced. Cisco's internal productivity metrics were going up, but their profitability advantage against their competitors was actively shrinking.
And to his credit, Tony Banta had the courage to face that inconsistency head on. He didn't just sweep it under the rug. He asked Dr. Barnard to do a theory of constraints analysis on Cisco's productivity measurement, and they found the culprit. It was a metric called revenue per FTE.
FTE meaning full-time employee.
Exactly.
Now, on the surface, that sounds like an incredibly logical metric. You always want more revenue per person. But here's where it gets interesting. How did the various departments at Cisco actually manipulate that metric to look good?
Well, think about the reality of a single department manager. Most departments within a massive, complex company like Cisco, they can't directly pull levers to increase the company's total revenue.
Yeah, they don't control sales.
Right. The sales environment, market conditions, that is entirely out of their hands. So if your performance is judged on revenue divided by headcount, and you literally cannot touch the revenue part of the equation, you are only left with one lever.
You slash the headcount. You get rid of the FTEs.
Precisely. You reduce your full-time employees by outsourcing the work. On paper, these departments were comparing their internal manufacturing costs to what external contract manufacturers were quoting them, and, well, outsourcing looked like an absolute no-brainer.
But let's walk through the specific math that was misleading them, because the numbers reveal how insidious this trap really is.
Yeah, let's do it. So Standard Accounting told Cisco that the cost to make a particular unit internally was $1,200.
Okay.
Now, a contract manufacturer comes along and quotes them $1,000 to make that exact same unit externally.
Okay, if I'm a manager looking at those two numbers, it looks like I just saved the company $200 a unit.
Right.
That is roughly a 20% cost savings. I am shrinking my headcount, lowering my cost, and I am definitely expecting a huge bonus this quarter.
But standard cost accounting hides reality. That $1,200 internal cost wasn't just cash flying out the door. It was actually made up of three distinct buckets.
Okay, what were they?
$400 in purchased parts, $400 in direct labor, and $400 in what accounting calls allocated overhead.
Wait, let's unpack that last bucket.
Yeah.
Allocated overhead. That's like the building lease, the management salaries, the electricity, the insurance. Right.
Exactly.
That $400 in overhead doesn't magically disappear just because you outsource the labor to another company. It's like, well, it's like selling your car to save gas money, but you still have to pay the monthly car loan.
The car loan is a perfect way to look at it because standard accounting deliberately obscures that loan. The true variable cost, like the actual money Cisco spent out of pocket to make that unit inside their own building, was only the parts and the labor.
Which is only $800.
Exactly. That totals $800. The overhead stayed no matter what.
Yep.
So by paying an external company $1,000 for something that truly only cost them $800 to make internally.
Oh, wow. They weren't saving 20% at all. They were actually paying 25% more to outsource the work.
They were bleeding money on every single outsourced unit. Yet because the internal headcount dropped, the denominator in their productivity fraction got smaller.
So the metric went up.
Yeah, the revenue per FTE metric celebrated this as a massive improvement. The measurement didn't just fail to reflect reality, it actively drove the company to destroy its own value.
That is wild. The metric actively rewarded them for making the company poorer. So, I mean, if revenue per FTE is a destructive ruler, what makes a good ruler? How do we actually know if a metric is helping the system?
To solve this, Dr. Barnard worked directly with Dr. Goldratt to define three mandatory criteria for any good measurement.
Okay, what are they?
First is status. Does the metric accurately tell us if we are okay, declining, or improving? Second is cause. Does it accurately identify what is driving that status?
Makes sense.
And third is incentive. Does it drive behaviors that are good for the entire system, not just the isolated part?
And if a metric fails those, we run into some serious systemic errors.
Yes. Borrowing from statistics, the paper notes that a bad metric causes type 1 or type 2 errors. A type 1 error is a false positive. The metric says you are improving, but you're actually declining.
And a type 2 error.
That's a false negative. You're doing great, but the metric says you're failing.
Which means Cisco's metric was basically a type 1 error nightmare. I mean, it failed all three criteria. Status, it said they were improving while profits fell. Cause, it pointed to headcount instead of true variable cost.
And incentive, it incentivized outsourcing that actively lost money.
It heavily drove a type 1 incentive error, doing what is bad for the system because the metric explicitly rewards it.
Exactly. So they needed a new framework. Now, Dr. Goldratt had already created a brilliant company-level metric in theory of constraints. It's called T over OE, throughput divided by operating expense.
Let me make sure we have the definitions right for everyone. Throughput is the rate the company makes money, and operating expense is the money spent to make it.
Correct.
That's a great ratio for the CEO. But, if I'm running an HR team or an IT help desk, I don't generate revenue. My throughput isn't cash. So how can I possibly use T over OE?
This raises the essential hurdle for applying theory of constraints beyond manufacturing. And it's exactly where Dr. Barnard's breakthrough comes in. He modified the equation to capture work output, not just revenue. He created TQ over OE.
TQ over OE. Let's define those variables for the listener.
So, T stands for throughput, but in this context, it means the quantity of work delivered and the time it takes to do it.
And the Q.
Q is quality. This is the critical addition. It represents the share of that throughput that actually meets customer expectations expressed as a decimal.
So if 90% of your work meets expectations, Q is 0.90.
Exactly. And finally, OE is operating expense, a total cost to produce that work.
Okay, I have to play the skeptic here for a second.
Yeah.
Let's say I'm a mid-level manager trying to apply this on a Tuesday morning. I do this math. I multiply my work quantity by my quality decimal, and I divide it by my massive departmental budget. I'm going to get a tiny, highly abstract fraction, something like 0.034. If I go to my team and say, hey, everyone, great job, but we really need to push and get to 0.035 this quarter.
Yeah.
How is that helpful at all? People don't think in abstract fractions.
You've hit on the exact practical problem they faced when rolling this out. A raw decimal means nothing to human psychology. So Dr. Barnard introduced a brilliant normalization step.
Which is?
You just invert the fraction. Instead of TQ over OE, you report it as OE over TQ.
So operating expense divided by, wait, let me think about that.
Follow the logic. Operating expense, which is dollars divided by your unit of quality throughput. Suddenly, that abstract fraction transforms into a simple dollar amount that every single employee intuitively understands.
Oh, I see. It becomes something tangible, like it costs us $47 to produce one quality unit of work.
You hit the nail on the head. You've taken a mathematical formula and turned it into a management conversation. If that dollar amount goes down, you are genuinely becoming more productive. If it goes up, you need to investigate.
That's brilliant.
And all three levers, quantity, quality, and cost, are entirely visible in that one single number.
I love the elegance of that. But it does raise a behavioral question for me. If I tell my team we need to lower our cost per quality unit, human nature says someone is going to start cutting corners just to make the number look better.
And that brings us to how you actually manage the work. Having the right metric is only half the battle. How you pursue improving it is the other half. What makes TQ over OE so powerful is that it functions as a self-correcting metric, but only if you follow a very strict 5-step priority sequence.
If it's a sequence to lower the cost per unit, I'm guessing step 1 is figuring out how to cut the most obvious waste, right?
That is actually the exact trap most managers fall into. Cutting expenses is priority number 4 out of 5.
Wait, really? Cost cutting is 4th? Okay, I clearly need the sequence.
Let's build it out. Priority 1 is more. You increase throughput to meet demand. Priority 2 is faster. You reduce lead time. Priority 3 is better. You improve quality to meet customer expectations.
Okay, so more, faster, better.
Then priority 4, and only after the first 3 are met, is cheaper. You reduce operating expense, but only if it doesn't harm throughput or quality. And priority 5 is simpler, removing unnecessary complexity.
Let's focus on why better comes before cheaper, because that defies so much corporate logic.
It really does.
If you cut costs first and you end up hurting the quality of the work, your Q decimal drops. And because Q is baked into the ratio, the metric instantly penalizes you. The cost per quality unit might actually go up because you're producing more junk.
Exactly.
It's like crash dieting to lose weight. The number on the scale looks better for a week, but your overall health crashes and you end up worse off than when you started.
That is a great analogy. And if you love mental models, the paper introduces a profound philosophical framework here for why we crash diet in business. It happens because we confuse goals with necessary conditions.
For the listener who loves a good framework, how should they visualize the difference between a goal and a necessary condition?
Think of 2 distinct curves on a graph. A goal, like overall company profit or mission impact, goes continuously upward. More is always better. But a necessary condition like speed or cost cutting or even quality levels has an optimal range.
Meaning?
It goes up, hits a peak of good enough, and then actually starts turning downward.
Are you saying you could be too fast or too cheap?
Absolutely. Think about driving a car. Speed is a necessary condition for getting to your destination, but speed is not the goal. If you push the necessary condition of speed past what the system can handle, you crash the car.
Get it.
If you push cheaper beyond the point where it supports the system, you destroy value. TQ over OE has built-in stopping rules to prevent this. Do more until you meet demand, but no more. Otherwise, you're hoarding unused inventory.
Right.
Do it faster until you meet customer tolerance, but no faster, or you burn out your team. This sequence stops you from optimizing a metric straight off a cliff.
Turning a virtue into a vice. I'm definitely stealing that mental model. All right, it's easy to see how a profit-driven tech company like Cisco can eventually correct. They have bottom-line revenue keeping them honest. But what happens when you apply this to a system that doesn't have a profit motive, like, say, a massive government bureaucracy?
This is where the framework proves it is truly universal.
Let's set the scene for the listeners. It's 2012. Governor Herbert of Utah issues a massive mandate. He wants a 25% productivity improvement across all 24 Utah state agencies.
A huge undertaking.
So Kristen Cox, the executive director of the governor's Office of Management and Budget, calls up Dr. Barnard. You can imagine the agency directors are absolutely panicking. They hear 25% productivity improvement, and they just assume that means flat 25% budget cuts.
Which is exactly how most governments historically handled efficiency mandates. Just across-the-board cuts. But Kristen Cox had worked with theory of constraints before. She knew they needed a breakthrough, not just austerity. They applied the TQ over OE framework across the entire state government.
Wait, I have to stop you there. How do you even do that for 24 totally different agencies? You can't compare the cost of issuing a simple fishing license at the Department of Natural Resources to the cost of resolving a complex child welfare case. trying to measure all of that just punish the agencies doing the harder work.
You are pointing out exactly why you can't just throw raw numbers into a giant blender. You have to cascade the metric intelligently.
How do they do that?
Each agency was asked to identify their top 3 to 5 core processes, things like issuing permits, resolving cases, serving citizens. They calculated the OE over TQ, the cost per quality unit, for each of those specific processes.
Okay, that makes sense.
Then they created a weighted average for the agency based on the budget share of those processes. It respects the complexity of the work. Finally, they rolled all 24 agencies up into one single productivity number for the entire state of Utah.
So they successfully tracked the entire state government on one weighted metric, the cost per quality citizen service.
Yes, and the mandate wasn't to slash budgets. The mandate was to bring that cost per quality service down by 25% by increasing the throughput and quality with the resources they already had.
And this leads to my favorite part of the whole paper, the hidden constraint. When they actually started measuring this way, they discovered something truly shocking.
Yeah, this part is amazing.
The traditional view was that these government agencies were just horribly understaffed and needed massive funding increases. But the TQ over OE framework revealed they weren't understaffed at all. They were drowning in something called failure demand.
This concept is an absolute game changer. Failure demand is work created by the system's own failures or delays rather than legitimate customer needs.
What does failure demand actually look like in practice for these agencies?
It's the fallout. It's a citizen calling the DMV in an absolute panic asking, "Where's my application? It's been 3 weeks." Or, "Why was I denied? How do I fix this error?"
So it's work that wouldn't even exist if the system had just done it right and on time the first time.
Correct. When they looked at the data, up to 50% of their capacity and 60 to 70% of staff time was being consumed by this failure demand.
That is staggering.
The constraint wasn't a lack of resources. The constraint was system delays that prevented existing resources from doing actual productive work.
So how do they actually clear it? If 60% of your time is spent answering angry phone calls, how do you fix the underlying flow?
By changing the metric to TQ over OE, they were forced to focus on predictable processes. Remember the sequence? Better, then cheaper. They stopped batching applications, which causes massive delays. They changed their triage systems to provide upfront clarity to citizens, which prevented the errors that caused the calls in the first place. By establishing smooth flow and stopping the upstream errors, the downstream capacity naturally opened up.
And the results speak for themselves. By clearing those delays, those failure demand complaint calls dropped 40 to 60%.
Yep.
Suddenly, 60% of their capacity was freed up to do real work. They didn't hit the 25% improvement goal in 3 years. They hit it in less than 12 months.
And they saved taxpayers over $100 million annually, all while maintaining quality ratings above 95%.
Incredible.
But there is a crucial objective takeaway here that we really need to highlight from the sources.
Right.
We often hear highly charged arguments about public versus private ownership. The idea that to fix a systemic problem, we either need to privatize a public service or bring a private supply chain under government control.
Right, the idea that the flag of ownership is what dictates how efficient something is. But the paper points out that we have to remain objective about what the data actually says.
Exactly. The white paper argues that neither Cisco, a private company that eventually had to bring outsourced work back in-house, nor Utah, a public entity keeping work in-house, found their secret in who owned the assets.
It wasn't about ownership.
No. The data evidence suggests that public or private ownership does not determine performance. What determines performance is whether every part of the system is aligned on improving flow, doing things more, faster, better, cheaper, and simpler.
Wow.
Change the measurement and you change the behavior regardless of whose name is on the building.
That really cuts right through the noise. So let's bring it all together. We have journeyed from Cisco's disastrous outsourcing illusion, where they were actively losing money but high-fiving over a green dashboard, to Utah's multi-million-dollar triumph in government efficiency. And it all hinged on swapping out a flawed one-dimensional ruler for a multi-dimensional mirror, TQ over OE.
If we bring this back to you, the listener, I highly recommend looking at the dashboards you are judged by, or the ones you use to manage your own team. If your metrics incentivize doing things cheaper over doing things better, you might be falling right into that type 1 incentive trap.
Yeah, that is a scary thought.
You might be celebrating on a spreadsheet while the reality of your work deteriorates. You have to be brave enough to ask yourself Jonah's question, are you measuring the right thing?
It is a phenomenal question. It is so easy to game a bad metric, but you cannot game reality forever. And I want to leave you with a final, lingering thought to mull over today. Think about your own daily workflow. Not your whole company, just your typical Tuesday.
Good point.
How much of your day is actually failure demand? How much of your precious time and energy is spent just managing the fallout, the endless clarification emails, putting out fires, handling complaints, all caused by delays and miscommunications in your own personal system, rather than creating real quality throughput? Fix the flow, and you might just get 60% of your week back. Until next time, keep diving deep.